Okay, question 1. Given the graph of y equals 2.45 minus 1.37x, okay, this is unavoidable. The decimals are unavoidable. Given the graph of y equals 2.45 minus 1.37x, we're not going to bother changing these two fractions. We're going to leave it as it is. We're just required to solve these equations here. So for each of these, we have done a similar example in a previous exercise. 2.45 minus 1.37x represents y, right? That's this expression over here. So essentially for all of these, we are being asked to find the value of x for which y equals 0, y equals 3, and this one is not in the form of what we are given, so we are just going to have to manipulate this. We'll actually do that now. Y is 2.45 minus 1.37x, so we're just going to take this term to the left. So we have 2.45 minus 1.37x, and what's left is minus 1.5, right? Minus 3 over 2, or minus 1.5. So now this one we're just going to solve for x where y equals minus 1.5, or y equals minus 3 over 2. If it's not in the form that you need it to be, then you need to put it into that form before we can answer the question. So now all we need to do is find these y values here on the graph and read off the corresponding x values. For the first one, y equals 0, y equals 0 is at the origin. Now we are going to move. This is the y position. We now need to move to the x position. So we move horizontally until we get to the line. So this is the point here at A. Now the x value, because we're working with decimals here, we're not going to get a nice neat integer value out of this. So we are going to estimate the value here. And it's not very clear from this graph. It's very, very unclear because we're dealing with subdivisions here. You need a very clear graph in order to read off these particular values. We're not going to get into this exercise because the graph is not clear and you want specific finite values of x. So we'll just discuss how to go about finding the x values. We'll use the solution to a, b, and c. So for the first one, where y equals 0, we move across to the function and read off the x value. That'll be at a. Where y equals 3, that is 3, we're going to move across to the function at this point here, drop a perpendicular, and we are going to read off the x value there. We'll call that point B. And then when y is minus 1.5, minus 1.5 is here. We're going to take a ruler, go across to the function, make the marking there, and then move perpendicularly up to the x-axis and read off that particular value there. And in this exercise, we'll do exactly the same thing. Y equals 0.46x plus 0.73. This represents your y value, so y equals 0. So where y equals 0, we're going to go to 0 on the y-axis and move across to the function and read off the value there. 0.46 plus 0.73, this is your y value, so y equals 2.5, or 5 over 2. We go to 2.5 on the y-axis, which is between 2 and 3. We move across using a ruler, we move across to the function, and then drop a perpendicular down to the x-axis and read off that particular value there. And then, okay, with C, we need to manipulate this slightly because it's not in this form, 0.46x plus 0.73. So 0.46x plus 1.73 equals 0. Okay, we're going to write this as 0.46x plus, we want 0.73. But remember, we have to write 1.73 in this form. So we have to add 1 equals 0. So all we've done is we've just written that slightly differently. And the reason we do that is because 0.46x plus 0.73 represents y. So y plus 1 equals 0. In other words, y equals negative 1. Another way of writing this equation is 0.46x plus 0.73 equals -1. In other words, we are now going to find y equals -1. Move across with the ruler horizontally until we get to the line. At where we hit the line, we then move perpendicularly up and we read off the x value. Question 3, we're given the graph of 2.7y plus 1.9x equals 4.42. For each of these a, b, and c, we are going to manipulate whatever's been given to us until it looks like that. So if we look at 1.9x equals 4.42, and what's been given to us, 2.7y plus 1.9x equals 4.42. You can clearly see that this quantity, 2.7y, over here is 0. So in other words, we're looking where y equals 0. So where y equals 0, we're going to move horizontally across until we hit the line, and we're going to read off that particular value of x. For b, we have 2.7y equals 4.42. Comparing it to the function we are given, clearly this quantity here is 0, right? In this equation here, that quantity is not there, so the x must be 0. So now where x equals 0 here, and we need to move up to the function, and at this point here, we are going to read off whatever y value is there. Again, we can't see it very clearly from this graph. We're just discussing how to go about answering questions like this. And then C, we have 2.7 plus 1.9x equals 4.42. Comparing it to 2.7y plus 1.96 equals 4.42. It's almost identical except for the fact that here we have a y, it's just not visible, it's actually 1. So in other words, y equals 1. So where y equals 1 is over there. We move horizontally across to the line, hit the line, and then drop a perpendicular down and get the x value, whatever it may be.